course, applications are where this all comes to most benefit. So let's look at a couple of applications. I was given some great seats to a baseball game. I was told that they were 50 feet from first base. And when I got there and I pointed my right arm at first base and my left arm at the home plate, there was a 75-degree angle formed between my arms. Now, if the distance between first base and home plate is 90 feet, how far am I from home plate? Now, just with what we're given, we got home plate, we got first base. I'm not quite sure if I'm 50 feet this direction or if I'm 50 feet if it's a right triangle, or maybe I'm somewhere between them. So I don't know exactly, but that's okay. We can work with that. So let's start off. We got home plate, we've got first base, and we know that's 90 feet between them. And we also know that I'm 50 feet away from first, and that if I point at first and home, there's an 85-degree angle here. I'm sorry, 75-degree angle. So how would we figure out how far I am from home plate? That's this distance. Well, I have enough information. I have a side-side angle. So this is the one that could be nasty, but we notice that the side that goes with the angle is larger than the other side that's given. So that tells us there's only one possible triangle. So let's continue with this. Let's just call that A, this A, that B. So angle B will be at home plate, angle C will be at first base. And essentially, to use the law of sines, I need to figure out what angle C is, and that will let me figure out what side C is. So let's just start with what we've got. We know that sine 75 degrees divided by 90, because 90 goes with the 75, is equal to sine of whatever B is divided by 50. So in other words, sine of B is 50 sine 75 divided by 90. So let's bring that up on a calculator. And I've already double checked this is in degrees. 50 sine 75, close my parentheses, divided by 90 equals. Gives me that number. Now I'm going to do my inverse sine of that number. And that gives me that B is about 32.5 degrees. Alright, so if A is 75 degrees and B is 32.5 degrees, I can take those from 180. 180 minus 75 minus 32.5. That tells me that third angle, which is actually the one I care about, is going to be 72.5 degrees. So that is this angle that is across from the side of the triangle that I'm looking for. So now we can use that along with the A's. We have that little a, 90, divided by sine 75 degrees is going to equal little c, which is the distance to home plate, divided by sine of 72.5 degrees. And since the angle is just a little smaller, we know that the length will be just a little smaller. And so if we do 90 sine 72.5, close parentheses, divided by sine of 75, we get that our seats are 88.9 feet from home plate. So it's almost an isosceles triangle there. One more. And this is another good case where we can use trig out in the real world. Redwood trees are hundreds of feet tall. From some point, I see the angle of elevation to the top of a tree is 37 degrees. I always like to build pictures. So here's our big redwood. And at some point I looked up, and this is 37 degrees. I walk 100 feet closer to the tree, so I walk 100 feet here, and now I look up and it's 44 degrees. So what is the height of the tree? Now we're going to have to do this in a couple of steps. First, what we're going to do is figure out what this side or this side. We got to figure out what one of these two lengths is. Doesn't matter which one we want to. Then we'll use that and whichever of the two angles we used to come up with this height, because this will be considered a right triangle once we get started. But for now, we don't have the right triangle. We just have this triangle. So let's start with that. 44 degrees. So if this side is 44 degrees, then the actual angle inside the triangle is going to be 180 minus 44, which would be 136. And then if this is 37 degrees, and if one angle is 37 degrees, one angle is 136 degrees, that's 173, so that means this angle would be 7 degrees. Now we can use this information. We know the 7 degrees and the 100 feet go together. So if we're looking for a distance, we've got 100 feet divided by sine of 7 degrees. And again, it doesn't matter. We could find this inner one. We might as well find that one since that's where we just walked to. I'm going to call it A right now. That's going to be A, and the corresponding angle to A is across from it. So that'll be sine of 37 degrees. And so we'll calculate this. 100 sine 37, close parentheses, divided by sine of 7 gives us 493.8 feet. Alright, so now we know what this hypotenuse is. So let's look now at our tree. Again, we're assuming the tree is going vertically. Not always a safe assumption, but we can use it for this. And we know that this angle of elevation is 44 degrees. We know that this hypotenuse is 493.8 feet. So let's see, this would be our opposite. We'll call it h for height of the tree. We also know that sine of 44 degrees will be our opposite, h, divided by our hypotenuse, 493.8. And so if we do a little multiplication, we get that the height of the tree is 493.8 times sine of 44 degrees. So 493.8 sine 44 equals, this tree is 343 feet high.